In the Ukraine, probably 5 million. There are a number of reasons for that, but certainly Lysenko's approach to agriculture was not exactly helpful. I mean, I have to defer to David Bellamy, who I'm sure knows much more about this than I do. But one of the interesting things about Vavilov was that he was undoubtedly a very significant botanist. He collected more seeds, I think, than anybody else had done. It said something like 250,000 species of plant he had from his travels all over the world. And here's an example of government control of science in a totalitarian regime. Another one might be here. In the center of this picture is Commandant Kramer, who was the head of Auschwitz, and on the extreme left of the photograph is Dr. Mengele. Mengele, of course, was a medical doctor who was interested in experimentation, and whilst I can't comment on Mengele's rationale, there is no question that one of the interesting things about the regime under the Nazis was that many of these doctors were actually altruistic. They believed that they were doing something which would improve their society. They forgot a very important ethical principle, that their responsibility is not to society primarily, but to the individual in front of them. So that twins like this, under Mengele, were converted to twins like this, under Mengele. And this is extremely well documented and completely irrefutable. But don't for a moment think that this misuse of genetics is confined to totalitarian or oligarchical or dictator type regimes. It has been true in democracies. And I want to show you as an example 2 karyotypes. Don't bother with the face of the fetus on the left-hand side, just look briefly at the 2 karyotypes. And what these scientists at the Carnegie Institute in America, one of the leading molecular biology institutes, are doing is showing that by drawing under a microscope, you can see very well that a white person is quite different genetically from a black person, even to the point of their chromosomes. And we can date this to about 1952, 1953, because if you count the number of chromosomes, there are 24 pairs, one more pair than are actually present in the human karyotype. And so we can say pretty accurately when this was. Now, the point I'm making here is that the scientists who drew this were not objective. They wanted to prove something that they believed. And this is something which continues in science, even in our own laboratories to this day. It's very easy to be persuaded by things that you want to believe, and believe me, I've done it myself. So I think it's important to recognize that it's very, very easy not to be objective. I don't think that actually we scientists are objective. I think we're like anybody else. And I think that's inevitably an issue, and I'm going to show you some examples of that. This is from my own work with Alan Handyside about 21 years ago, but it shows embryo biopsy, and here, for the first time, what we're doing is taking a cell from an embryo. This is time-lapse photography. We're taking a small piece of the zona pellucida and dissolving it with a tiny drop of acidified tyrode solution. Bear in mind that the whole structure is about 100 microns across. And then from this, we can remove one cell. And what Alan and I did was to refine PCR, the polymerase chain reaction, from what was then possible, about 200 cells, to make a single cell informative. And using this technology, we were able to get the first babies which were free of specific gene defects as a result of this work. The embryo looks damaged, but before we started transferring human embryos, you may be sure we tried this technology in at least 6 or 7 different animal species. The first births were just over 20 years ago. These 2 girls are now 20 and a bit, Lisa and Harriet. Harriet is on the right-hand side, and of course the press called them perfect babies or designer babies, something we still hear today. They're nothing of the kind, they're not perfect babies. The only difference between them and their elder brother, age 4, who died of adrenoleukodystrophy, was a single base pair deletion in the 3 billion pair human alphabet. So there's no design and no perfection here. This is entirely random. But of course, this has been consistently misrepresented by the press and still is. And I think it has adverse consequences on public acceptance of what we do. Harriet is not a perfect baby. Look at the blemish on her chin. Incidentally, that's not because we took a cell away, that's because she fell over 7 hours before the photograph was taken. But it didn't stop Harvey Lodish, one of the world's leading molecular biologists, to write this in one of the leading journals, Science, about our work a few years later. I won't read it out to you, but what Harvey Lodish is saying is that it's now possible to remove a single cell, and of course, once we have the complete understanding of the DNA alphabet with proper sequencing, we will be able, together with understanding the expression of proteins, will be able, at the time of in vitro fertilization with embryo biopsy, to make a color movie where we can demonstrate how the embryo will develop in the future, its size, shape, and hair and skin color. And once we've got the DNA sequence base fully expanded, we'll be able to cover genes which are important for speech and musical ability, so that in a few years' time, a mother undergoing in vitro fertilization will be able to hear her baby speak or sing. It's very flattering sometimes when you get people writing about your work in that kind of way, but it is complete nonsense. And it's a very good example of a piece of technology which has been hugely overhyped. I don't think that what Alan and I did was that important anyway now. It's still being used, of course. The experiment in Newcastle is a kind of extension of the same process, but it's not that new, and it may only help at best a handful of people who are desperately in need, but it's not going to shake the moral fabric of our universe if it's used or not used, actually. And that is something which we have to understand. It's a sense of proportion about the science we do. And in any case, our slavish attention to genetics is wrong. If you look at if I asked you what was the biggest development in biology in the last 10 years, I suspect that 90% of you would put your hand up and say the sequencing of the human genome. And in my view, I think you'd be wrong. When the Wellcome Trust announced the sequencing of the human genome, Mike Dexter, the head of the Wellcome Trust, said this is more important than the invention of the wheel. Well, it might be, but it's a wheel that hasn't actually revolved 8 years later. Actually, the human genome has not been very useful so far. It might be in the future, and it's useful for us as bench scientists, but it's not useful to the average man in the street, and it's very doubtful whether genomic medicine will be useful except for certain forms of cancer in the future. That is still quite debatable. We all think it might be, and we like to believe it will be, and we want to see it improving. But actually, if it's to do so, the massive investment that would be required in informatics, in pathology services, in education amongst doctors and people who are working in science would be absolutely huge. And at the present time, I think it's unthinkable that we will be able to implement genomic medicine in any serious way. And in any case, it forgets an important issue. We tend to think of our existence as being nature or nurture. And that actually is no longer a concept that was acceptable. This little diagram is taken from a paper of Françoise Champagne from the University of McGill and Montreal. She has done a classic piece of work where she's looked at high grooming and low grooming mothers' rodents. And it turns out that some mice are low groomers. They just don't look after their offspring very well.